Many months ago, I took this out of the plasma TV from the junk and was set to get it fixed up. Well, I finally got around to taking a look at it. We got some parts. Let's finish up this project.
This episode made possible in part by PCBWay. Check them out at the link below for all your custom printed circuit board needs. They offer numerous services, different styles of PCBs, even assembly and parts supply.
Okay, so this is the board out of that big monster plasma TV, which was dead. And I'll post the link down below to the previous video if you want to check it out. Now, what I did is I went over this board and I measured the capacitors on it. In consumer electronics, it's always the capacitors. It's always the electrolytic caps. These ones, they're not really overly bulged. There's not a lot of sign of damage, but what I did do is I took my ESR meter and I went over them all, and they were off. These ones are off, and a few of these smaller ones over here were off. So what I did is I went to DigiKey and I went shopping. And I just ordered replacements for all of the ones that measured remotely bad, particularly these big monsters. And this should get us in gear and going. These ones are a little bit higher, so that could be a problem. This is the thing with caps, unless you really pay attention. It looks like these ones are significantly higher. But we'll take a look. We'll see, and we'll go ahead and pull some off the board, and let's fix this thing up. You don't need an ESR meter. It does make life a lot easier. They're not that expensive. You just measure the equivalent series resistance of the cap, and it'll show a failure in these cases when you can't see a bulge. But you can also just go ahead and change the caps. It's always the caps. Okay, we'll start out with these monsters, these big 330 mic ones, and let's see how we did. This was a long time ago, so I can't ship these back. DigiKey, it's expensive, but it's quick, it's simple, their catalog is easy to shop from. So 450 volt, 330 microfarad, and they're higher. I don't think we're going to have clearance issues. If I remember right, the case is quite a ways back on this. And if it's not, we're going to modify it because I'm not reordering any caps now. So those two should be direct replacements for those. Pretty simple stuff. We're just going to remove them, observe the polarity, put them back the way they came. Next up, I'm guessing this is that big 250 volt. It's been so long I don't even remember what I found on here. So this is, yep, it's that big 250 volts. So it's this big guy back in the corner that measured off. So that guy there, that's got him looked after. And then these I think are going to be a problem. Are these going to fit? 470, 100 volt. 470 mic, 100 volt. 4 of them. Is that these guys? I hope not, because it's not going to fit. Those are definitely not going to fit. No. Oh, there they are. 470, 100 volt. 470, 100 volt. There and there. Why did I get 4 of them? 470, 100 volt. Was there a minimum quantity? Anyway, it's those two right there. Those two, this guy, those two. Let's change them out. See, these ones appear to be fine. That one looks like a little, how you doing? But we'll start here, and then we'll see where we land. Okay, I've got my cheapo fume extractor there running. Fired up the WEP solder station. I went ahead and I marked on here the polarity just on the heatsink, so I remember which way to put them in. Let's go ahead and pull these monsters out. So this 250 and then these 470s. So what we can do, hopefully my iron's warmed up, we can go ahead and introduce some kind of fresh solder on there so that we can get that to flow. This thing is, she's a monster, so it's going to be a challenge. It's a heavy duty board too. That did not do anything, so my iron is not warmed up. We'll come back when that's warmed up. Okie dokie. That is very, very big ground plane and stuff, so these are going to be a challenge. That solder sucker sucks. That's just a kind of an El Cheapo solder sucker. Not the best. So we may... Where's my old one? Sorry about that. I went ahead and grabbed my auger and I just heated them both and it just fell right out. So there's our holes. We're just going to clean those up with some fresh solder. I won't cut away this time. Try not to move you guys. So just put some nice fresh on there. And should we use the solder sucker or should we... Where's my... Lost my wick. There. Perfect. Look at that. 2 nice holes through the board. And I think what I'll do is I'll go and take the other ones out right now. Oops. I think what I'll do is take the other ones out right now too, because this gives me a little bit more room to maneuver in there. So let's try this. Look at that crummy solder over there. Might have to put just a little bit of fresh. There's a little bit of flux on there. Because why not? It does sure help with heat transfer sometimes. And then we can, well, it's warm, hopefully. You can start working it from the backside and work it on out of there. Wiggle it loose. Once it's sort of loose and maneuverable, the leg won't reharden the solder. You know what? So I've got just the right amount off of there that I can't conduct any heat energy back into it. So I'll just go ahead and hit it again. And then this time we'll just pull it right out. And that's that. Just like that. Now we'll go ahead again. Add a little bit of fresh solder sucker. Done. Done. This one's not perfectly empty. Now it is. Perfect. Happy, happy. This time we'll skip right to putting some fresh on there. Back and forth. We're almost there. Out. Done deal. This guy down through. Perfect. This guy down through. Beautiful. Where's that big monster? Not that one. Where's the new one? Oh, maybe that is the new one. 250, 820. 250, 820. This is the guy. I want him. Oof. I might have to sort these leads out. That's not perfect. Maybe? Oh, got lucky. I think I just got lucky. Yep, sure did. She's through. Wonderful. Through the holes. You can spread these a little bit. Give them a little pull. Little pull. Little spread. just to hold that cap up against the bottom. What I'll do is I'll reach behind and just hold it up while I touch some solder on there. Okay, which one do we start with? Let's start with this big one before it falls out of there, because that might be a well and true. I'm surprised that I got those little short terminals through there so easily and quickly, actually. So, you need a lot of heat for this. This is my old Unger. We're just going to let it soak right in case this is a multi-layer board. That looks good. Oh yeah, that looks wonderful. Yeah, that is a lot of copper to warm up. You need a beast of an iron. There we go. This old Unger is quite slow on the temperature control. She takes a second before it kicks up a notch and goes to high heat, but once it does, there we go. Beautiful joint. Beautiful, beautiful. Alright, so these ones shouldn't be quite so bad. Reach around. There we go. Just holding up on that a little bit from the backside. I don't think I'm even going to need to on this one. And boom. Happy, happy. Alright. Just like so. Wash, rinse, repeat. Go ahead with our snippy snips. Alright. 2 more big monsters to go. You guys get the idea, right? I don't think you probably want to watch me swapping these ones out too. Where are they? Here and here. I think what I'll do is I'll put just a little bit of flux on these ones again. Help with that crappy lead-free solder and get it to flow. I think what we'll do is we'll just move right to hitting these with fresh solder. Now that we know kind of what to expect from this board and this solder, we'll go ahead and just add fresh. Yeah, that doesn't even want to flow down through. Come on. Oof. It's a lot of metal. Getting there. There she goes. There she goes. And we'll just go down through and give her the wiggles. I don't know what the odds of being able to heat both up simultaneous on these ones are, but we'll try. Can you see that? Kind of, sort of. Just make sure when you're done doing this, you'll notice that I'm not exactly being the most careful with my solder sucker when I'm dumping the waste. Should be a little bit more careful. Just go back over your board when you're done and look for errant solder that has made its way to places it shouldn't be. It'll be hardened by the time it lands on the board, so it's not hard to remove. It's not like we're splashing big goobers of it everywhere. Okay, we're gonna put these guys in this way. Hopefully it's the right spacing. We got lucky on that first one. It just slid right in there. Can you even see? Nope. You cannot see. Reset. Okay. Here's our spots where our caps need to go. With any luck, these will slide right in there. That one did. That one did, and the terminals are holding it. I wonder if we move fast and effective enough, we can get this one in. See how there's an insert? I don't know whether you can pick that up on camera because the autofocus is probably going banana pants, but they have inserts in there, and that's why this was such a fight. It's a lot of metal to warm up. Okay, we're in. Okay. We're flowing. I never know whether to edit these videos right down and take out all the slow, quiet parts, or whether I should leave it kind of raw. But there we go, guys. There's our joints. Done like dinner. There's one solder blob I saw get away, but I'm just going to go overhead and kind of clean things up, look for any splashy splash from my solder sucker, and this thing's ready to go back in the TV, and we'll cross our fingers that it's going to work. Oh, this is downright miserable. 110 kilometer an hour winds. Woo-hoo. Blizzard warnings. Great fun. Let's go. Oh yeah. Nice and warm in here though. Perfect. Okay, this is the old TV. If we can remember how it goes. Sorry about the fan noise. I will just go ahead and put this back together. I can remember how it was about. Oh, I kind of remember. Yeah. I'll figure it out. Okay, as Dave would say, we're in like Flynn. I went ahead and plugged everything back in. It looks like I remember marking that connector was unused. All the rest of these went back into their homes. I don't have all the screws in this board because truthfully I don't know whether this is going to solve it or whether we're going to have to go further. I didn't like the amount of corrosion that was in this thing. When I got it, it had spent some time outside, so there's lots of other boards here that have all kinds of electrolytics on them too. But when we tested this, if you didn't see the original video, I did trace it back, and these are all labeled. It's wonderful. All these rails, and there was nothing. There was no 5-volt rails at all coming out of this power supply. So fingers crossed. We'll see what happens. I'll do it live. Get your fire extinguisher. Okay, let's see. Do I have a power cord? Do we have the power? We do have the power. It's got a zip tie on it. Why did I do that? Contact. Don't blow up in my face. Don't blow up in my face. Don't blow up in my face. That click was from the other speakers firing up. Okay. I don't remember where the heck the power buttons and stuff were on this thing. I didn't get a remote with it. I remember that much. It didn't blow up. That's a good sign. Alright. Let's find. Clickers. They look good. Wah, wah. Hello? Well, thou shalt measure voltages, I guess, again, and we'll see what we find. Alright, for my own future reference, this is very strange. So we've got 110 volt coming in, 115 volts, 115 there and there. But if we go over to here on our AC terminals, which are labeled, this must be a rectifier of some form. I'm only getting half a volt there, and nothing. Same on these buses here. It seems like all the 5 volts are dead. I checked all of them. Everything is dead still. It's deader than a doornail. It looks like the problem is in our high voltage section here, which is kind of interesting to me, because that's not at all what I expected to fail. And I bet you it's probably a common failure mode we've got all these, I don't even know what kind of a MOSFET or whatever they are, but it's all in the high voltage section here, all in our main section and our big filters. Oh, anyway, I think I'm gonna have to get a schematic, because although the board's labeled fairly well, I can't make heads or tails of what's what, and I'm wondering, we must have a big open, because everything is dead. And everything is not only dead, it's flatlined at 0. There's no floating, no nothing. Everything is just 0.00000. I went and got my fluke to check it. So it's very strange behavior. I may publish this video as it is and see what you guys think. I set that up where you can see it. Yeah, you can barely. So if I go on any of the 5-volt rails here, notice how we're not, actually, a little less now. Okay, well, it's not flatline deader than hell now, but it is at 0. So she's hooped. I didn't get her to fire up. There's a big diode in here, and this is even quite strange. This big diode measuring on it is a strange value. This is right in the main section, 2.7 volts AC. So some things are kind of half there. 2.7 volts, that's an odd value. Really odd. I don't know any rail, or unless it's just in kind of in limbo there, but I don't see anything blown all to hell. So those caps were bad, no question. The ESR was out to lunch on those, and there's one, maybe two that are still a little cattywampus, but I don't know. I think what I'll do is take some pictures, and actually, here, I'm gonna post it. You guys, I'm gonna post this video up. What the heck? So there's a one model number. There's another one. I think that might be for the chassis. There's that. There's that. And I think that's about the extent of things with model numbers. But I have mains coming in all the way up to the power supply board, and then everything from here is where it falls apart. She's splat. So yeah, if you've got any ideas, post them in. To be continued.